Hey, welcome pre-calculus. Here's our do now for today. Go ahead and hit pause on the video while you answer these questions for yourself. All right. Hey, so this one is in standard form, and we can recognize that because there are no parentheses. It's not factored. Each of the parts of the equation separated by a plus or minus. Part B, the degree is 3. We're going to find the biggest exponent. That's what we're looking for in standard form. Factored form would be different. And C, the leading term is really a so-called leading term because it's not in the beginning. Since this has been scrambled up, we got to find where that degree came from, and that is the quote leading term, so 7x to the power 3. And then part D, the leading coefficient is that plus 7 from the previously mentioned term. All right, so today we are looking at properties of polynomials. We're going to be using all of the properties that we've been studying about polynomials in order to draw graphs today. So what are some of the things we've been learning? Well, we've looked at end behavior of polynomials. We have looked at how to identify the number of x-intercepts that a graph will have, the number of direction changes present, the shape of the x-intercepts determined by the multiplicity of the factors. All of this stuff is going to go into making graphs today. So let's take a look at a couple of examples. We're gonna, for the following functions, we're gonna find the end behavior first. It will identify the intercepts, also called zeros, and the multiplicity at the intercepts. And then we can use the equation to find some more coordinates, to plot a few more points in the table of values, and then we'll make our graph. So here is our function. Let's get the degree first of all. In this equation, it's in standard form. We can see the degree is 2, which is an even number. The leading coefficient is negative, and that means our end behavior for an even degree with a negative leading coefficient is going to go down at the left end, down at the right end. Let's find some x-intercepts, or zeros as they are called here. And so we've got a green factor. Let's look at that one first. Green factor is going to give me an intercept at coordinates -1, 0. And the shape of the graph there, since that has a multiplicity of 1 on that factor, it's going to make a line shape. And then let's look at the blue one. The blue factor will give us an intercepted coordinates 3, 0. And since that also has a multiplicity of 1, we'll get a line shape. All right, so on our graph, I'm going to put the, I'm going to find one more piece of information. Actually, let's do the y-intercept. So to get the y-intercept, we got 2 options. I'll show you another option. We have pick either the standard form or factor form, either way. Change the x's to 0. That'll give us the y-intercept. So I'll have, if I'm looking at standard form, -0 squared, that'll be 0, plus 2 times 0, that's also 0, and then plus 3. So y-intercept is going to be 0, 3. And then just to make sure we're all aware, here's a shortcut. In standard form, that plus 3 at the end is always going to be the y-intercept. Yesterday, we were plugging in zeros because it was the only option we had because we were working from factored form. But if you're in standard form, that constant at the end, it's got to have no x on it at all. That'll be the y-intercept. So 0, 3, it's going to give me one more point. So once I've identified the end behavior and the zeros and the shape of the graph at those zeros, I'm going to plot points onto my graph. So an x-intercept at -1. I've got another x-intercept at 3, 0. I've got a y-intercept at 0, 3. And then I'm going to put the end behavior next. So points, coordinates of points first, and then the end behavior. So at the left end is going down. So I'm going to go to the farthest left point that I have put on the graph. And from here, the graph will go down. Okay. At this point, I don't actually know how steeply, that should be going down. So artistic license for now. The only way that we can find out exactly how steeply that part of the curve is going down would be to complete a table of values, which we can look at in a minute. And the other end is going down also, so I'm going to go to the furthest right-hand dot that I've graphed, and from here the graph will be going down. Again, I don't know exactly what steepness to draw that, so artistic license for now. And then let's talk about the shape of the graph at each of those x-intercepts. I like to work across the graph from left to right, so I'm going to start with the green dot. At the green dot is making a line shape. That line shape through the green dot needs to match up with the end behavior I just drew. So through that green dot, I'm going to have a line shape. And then the graph is going to continue. I have a y-intercept, so I need to go through the y-intercept. But then once I've done that, I don't know how high the graph is going to go because I don't know that. Again, the only way to know that for certain would be to complete the table of values. So at some point, I'm going to turn around. I have to head back down to get to the next point, which is that blue dot. And then at the blue dot, my line shape x-intercept needs to connect the parts of the graph that I've already drawn. So going through that blue dot, it should make a line shape. All right, so it's a pretty basic graph. It's just, as it turns out, is a parabola opening downward, which we probably could have graphed differently. But here's what I would recommend for table of values. So I'm going to take the coordinates that I already have, -1, 0, 3, 0, and 0, 3. I'm going to put those into this table, and then I'll fill in some more x values. -2, +1, +2, 3, 0 I've already got, 4 and 5. I don't need to do all of them. The directions up here say vaguely that I should do the coordinates of a few more points. And so we'll do a couple. So I'm going to take the equation. I'll just write this down. And you could use your calculator to do this if you want. You could do this mentally. So I think really the thing I am most interested in is I want to find out the red section of the graph right here. How high up does that actually go? And so I would find that information by getting the coordinates for an x value of 1 and for an x value of 2. So that's where I'm going to start. Then we could find more information by completing more values to complete the table of values. So let's try +1, which is right on the top of this. Change this to a 1. So -1 squared, that's -1. 2 times 1 is 2, and then +3. So -1 + 2 + 3 gives me 4. What if I wanted to find out for an x value of 2? Okay, again, we'll just do this the messy way. I'm just going to write on top of that. So -2 squared. So do the exponent first. Negative comes after. So 2 squared is 4. Make that negative, so it'll be -4. And then plus 2 times 2, that's 4. And then +3. -4 + 4 + 3. Y coordinate is 3. Okay, so I could plot these points on the graph, and that would help me to have a more accurate graph. So this little red part right here, I'm just going to remove that and plot the points that I just found in the table of values. I can do a better job now. So I've got coordinates at 1, 4, and then 2, 3. Okay, so that'll give me a better idea of actually how high that graph is going as it connects from the red section to the blue section. Just got to connect through the dots. Right, if I wanted to find out more information about the downward sections, the end behavior, then I would need to do some more values in my table of values. All right, example number 2. Same directions, make a rough sketch of the slightly different wording, but same directions. Make a rough sketch of the graph using end behavior. We'll do that first, and then the zeros, and then the multiplicity of those zeros to make my graph as accurate as possible. So the degree is 4. That's even. Leading coefficient is negative. End behavior for an even degree and a negative leading coefficient is going to be down at the left, down at the right. My zeros come from this root, this root, and this root. So the green one is going to give me coordinates of 0, 0. That has a multiplicity of 1. It's got an invisible 1 on there, so that's going to make a line shape. The blue one is going to give me coordinates 2, 0. That one's got a multiplicity of 2, so this will be a U shape. And that magenta one, negative 3, 0, and that one is also going to be a line shape since that factor's got a multiplicity of 1. I'm plotting my points on here. 0, 0, 2, 0, negative 3, 0. I'll do the end behavior next. So go to the left, furthest left point. That goes down, furthest right point. That goes down also. I'm going to go from left to right across the graph. So that purple point, the graph's going to make a line shape through there. And then the, actually, maybe we'll not go all the way from left to right. So then I got the left end behavior connected. At the right end, that would connect to the blue dot. At the blue dot, it's going to make a U shape. So as I'm looking at the right-hand side, coming up to the blue dot, this is going to make a U shape as it touches that blue dot. And then if I'm visualizing ahead, the only way I can connect the purple section to the blue section is you're going to have to turn directions and go through that green dot. When I do go through the green dot, it's going to make a line shape. So how do I know if the line goes like this or like this? Well, I got to visualize a little bit. The only way I could possibly connect the purple and the blue parts of the graph and still have this be a function is if my line goes like this. And then shoop, I'm going to connect this part of the graph. I'm going to connect this part of the graph. Again, that's a little bit of a messy artistic license as far as how high up that bump goes, how far down that local minimum is going to be located. Again, if I complete the table of values, I'll get a more accurate graph. Right, so let's take a look at what does happen when we use the table of values. So I'm going to take these 3 points that I already have coordinates for, 0, 0, 2, 0, and negative 3, 0. I'm going to record those as some of the values in my table, and then fill in the rest of the x values counting by ones. So if I was going to use this table to get some more information about the graph, I would want to know something about between the purple and green dots. I don't want to pick one of these two, maybe both, but one of those 2 points for sure. And that'll tell me how high this bump goes up so I could graph it more accurately. And then I might also want to pick a value between the green and the blue points. And there's actually just the one x value there. So I'd probably want to get a value for x equals 1. Then if I want to know some information about the ends, how fast are those ends going down? I know they're both going down, but how fast? Then I could pick one of the x values either to the left to get something about the left end, so like negative 4, negative 5, negative 6, but negative 4 is the only one I have written down. And for the right end, something past that blue dot, so like positive 3, 4, something like that. So I'm going to take the function. I copied this down here, the standard form one. You could use either standard form or the factored version. Either way, you're going to get the same answers. And let's, just as a demonstration here, let's do positive 1. It's an easy one to demonstrate. So I'm going to change all of these x's to positive 1s. So positive 1 to the 4th, positive 1 to the 3rd, 8 times positive 1 squared, and 12 times 1. So starting from left to right, 1 to the power of 4 is 1. Make it negative, so that'll be negative 1. 1 to the 3rd is 1, so plus 1. 1 squared is 1, multiplied by 8 is 8. Whoops. 8, there we go. And then 12 times 1 is 12, so minus 12. Negative 1 plus 1 is 0, plus 8 is 8, minus 12 is negative 4. So there's my y coordinate. Okay, so now I can, at this point, I can make my graph a little bit more accurate. So I should have a point at 1, negative 4. So the little bump that I drew does not actually go down far enough. So I can drag that down so that it'll hit at 1, 2, 3, right there. And then we can just make those lines a little bit longer so that it actually connects. Maybe I should just redraw this. It's going to be hard to connect. Let me just get the shape a little bit. It's not drawing very well for me, so this is a slower process than what I'd imagined. And there's my little dot at 1, negative 4. Okay, so perhaps you can draw your graph faster than I was able to do it just now. But so I'm able to get a little bit more information and find a way to more accurately graph the points. I could continue the process for this section to see exactly how high up that bump should go. So I just need to evaluate at negative 1 and negative 2. And we can demonstrate that. Let's just do negative 1. So we're going to change all those x's into negative 1, negative 1, negative 1, negative 1, by some more space. So negative 1 to the power of 4 is positive 1, but then make it negative. So that's negative 1. Negative 1 to the power of 3 is negative 1. A negative 1 squared is positive 1 times 8 is 8. And I'll just call this a negative 12 times negative 1 is positive. So we'll just say plus 12. So negative 1 minus 1 is negative 2, plus 8 is 6, plus 12 is 18. All right, well, that gives me some coordinates, so it's not going to fit on my graph. So without even doing the other point, I know already this is going to have to go way up there, and I don't have 18 spaces on my graph. So I'm still not going to be able to draw it super accurately because it doesn't fit on the graph, but at least I actually know where it's supposed to go. This is supposed to go, wow, that was a terrible drawing. Up, 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 and I should go through that point, negative 1, 18. So then I can continue this process to find more points. Yeah, I'm not going to expect you to graph all the points that are not on the graph because they don't fit on the graph, but we can at least get a better sense of what the graph should look like. This graph should look super messy. Oh my goodness. Let's see if we can just redraw this. It looks, that's the worst. Okay, that looks somewhat better. So anyway, it goes way up there. So the local maximum is going to be very high. I'm actually not sure yet if the local max is going to be at negative 1 or at negative 2 because I didn't evaluate at negative 2 yet. So that's how the table of values works. All right, last example. So we're back to the same directions we had before. We're going to make a rough sketch of the graph using n behavior zeros multiplicity. So I think at this point, probably we can go a little bit faster. So I'm going to look at that function, and I need to decide about the degree. Well, I can see the degree is 5, or in the factored form, I can add together those two exponents. Either way, it's 5, and that is odd. Leading coefficient is positive. And so I've got an odd degree and a positive leading coefficient. So at the left end, it's going to be going down. And at the right end, it's going to be going up. All right, so I have some zeros. So I have to erase that stuff. I can't see anything anymore. All right, so I've got two factors. Got the x squared factor and the parentheses over here in blue. Let's do the green one first. So I'm just going to be at 0, 0. Multiplicity on the green one is a 2, which is going to give me a U shape. And then for the blue one, my coordinates, -5, 0. And you can take the whatever's inside the parentheses, x plus 5, make that equal to 0, your little algebra equation, solve to find x. So I'm going to subtract 5 on both sides. And then for the blue one, the multiplicity is 3, and that is going to give me an S shape. All right, let's get some dots on the graph. Oh, I could find the y-intercept here. The y-intercept is going to be 0, and I've already got that as one of my x-intercepts. I can write it down, but it's not going to give me any more points on the graph because I already have 0, 0 identified as a point. So there's 1, and then 1, 2, 3, 4, -5 is right there. I'm going to put the end behavior on the graph first, going down to the left, going up to the right. And now let's get the shape of the graph at each of those x-intercepts. Let's start with the blue one. So the blue one is supposed to make an S shape. It's going to have to connect to the end behavior that's already there, which means I'm going to have to go up flat and then keep going up. So I've got that S right through the blue dot. And then visualizing ahead, this graph is going to probably go way, way up there. We'd have to use the table of values to find out, but somewhere it's going to have to turn around. So there's going to be a local max up there someplace. It turns around. It's got to turn back around and come down to hit the green dot. And then the green dot is supposed to make a U shape. And that is perfect. That U shape will connect the one part of the graph where the local max is to the end behavior. And that means everything works out just well. So there's my graph. If I want to get more detailed information about how high this local maximum is, I would need to do my table of values. If I want to know how fast does the graph go up towards the left end, I would need to find some coordinates using a table of values. Same thing with the right end behavior, the left end behavior. If I want to know how fast it's going down, I'll need some coordinates, and I could use the table of values to do that too.